Welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to continue looking at integration with basic trig forms. So in the previous video we did 6 basic trig form integrals. They were the reverse of finding the derivatives of your 6 trig functions. But there are 4 more trig integrals I want to talk about in this video. I want to talk about how to find the integral of tan u du, cotangent u du, secant u du, and cosecant u du. Those are not the derivatives of any of the other trig functions, so we have to figure out how to integrate these. Instead of just jumping in and telling you these formulas, I'm going to do a couple of examples and show you where the formulas come from. So for example, if I had a question that asked me to find the tangent of x dx, I don't know that integral, but I do know that tangent of x can be written as sine of x divided by cos of x dx. And then I can write that as 1 over cos x times sine x dx. And if I go back to my patterns of integration that I've looked at so far, this appears to be a 1 over u pattern, where u is cos of x. The du factor, the derivative of cos x, is negative sine of x. So the du factor will be negative sine x dx. I don't have the negative, but that's not an issue. I'll multiply by negative 1 as long as I also multiply by negative 1 outside the integral sign, so that I haven't changed the value. Now that I have the du factor, I can integrate this using my basic log pattern. The integral of 1 over u du is the natural log of the absolute value of u. So this would be negative natural log of u, which is cos of x, plus c. So I was able to integrate that based on trig identities and a pattern I've looked at previously. So this integral would be negative natural log of the absolute value of cos of u plus c. We could use the same idea to integrate cotangent of u du. For example, if I had the integral of cotangent of x dx, I could write that as the integral of cosine of x divided by the sine of x dx, and that's equal to the integral of 1 over sine of x cos of x dx, where this is 1 over u, this is the du factor, so this integral would be the natural log of the absolute value of sine of x. So therefore, the integral of cotangent u du would be natural log of the absolute value of sine of u plus c. This next integral is a little trickier, but what we're going to do is try secant of x dx. And then I'm going to introduce something here. I'm going to multiply the numerator and the denominator by something. Right now the denominator is a 1. And the something that I'm going to multiply by is secant of x plus tangent of x. Then what I'm going to do is distribute that. And that's going to be secant squared x plus secant x tan x. And then what I'm going to do is write that as 1 over secant of x plus tan of x. And then I'm going to write this beside it, but I'm just going to change the order to secant x tan x plus secant squared x dx. And again, if I look at this as a 1 over u, this is actually the du factor. The derivative of secant x is secant x tan x, and the derivative of tan x is secant squared x. So this whole thing is the du factor. So the integral of that will be the natural log of the absolute value of secant x plus tan x. So generalizing that, the integral of secant u du will be equal to the natural log of the absolute value of secant of u plus tangent of u plus c. We could do this much the same way, and if we did that, we would get the natural log of cosecant of u minus cotangent of u. So let's take a look at using these 4 patterns in some examples. So our first example asks us to find the integral of 3x times tangent of 4x squared dx. So I'm just going to do a little bit of manipulating. I'm going to pull the 3 out front. I'm going to bring the tan 4x squared first, and I'm going to write that x behind because I already know that x is going to be part of my du factor. If you take a look at this, 4x squared, the derivative of 4x squared is 8x. So I need that x as part of my du factor. So the pattern I'm going to be using is this first one, where my u is 4x squared. The du factor will be 8x dx. So I need an 8. I multiply by 8. I also divide by 8 outside the integral sign. Now it fits my pattern tan of u, and I have my du factor exact, so I can plug into my formula. So it will be negative 3/8 times the natural log of the absolute value cos of 4x squared plus c. Let's try some more. We're going to be using this pattern for this question. We have the secant of u. So let's define what u is. So u will be 2 pi t. So the du factor will be 2 pi dt. So I need that factor. So I multiply by 2 pi. I also divide by 2 pi. So now it fits the form secant of u du. And now I plug into my formula. This integral will equal 1 over 2 pi times the natural log of the absolute value of the secant of 2 pi t plus tangent of 2 pi t. Let's keep going. In our next example, we have the integral of cotangent e to the negative x divided by e to the x. So let's separate. We don't want that quotient. Let's separate these, and I'm going to write this as the integral of cotangent e to the negative x. I'm going to bring this out of the denominator. So 1 over e to the x will be e to the negative x dx. This appears to be integral of cotangent u du. So if this is cotangent u, u is defined as e to the negative x. So the du factor, the derivative of e to the negative x will be e to the negative x times the derivative of negative x, which is negative 1 dx. So I need a factor of negative 1. I can multiply by negative 1 as long as I also multiply by negative 1 outside the integral sign, so that when those multiply, they're equal to 1. Now I have my du factor, so I can integrate. My integral will be negative natural log of the absolute value of sine of e to the negative x. Let's try a few more. In our next example, it's a power, but in order to integrate this, I would need the derivative of 1 plus secant x as a factor. I don't have that, so I can't leave it as a power. So what I can do is break that up and multiply it out. So that's 1 plus secant x times 1 plus secant x. When I FOIL that, I'm going to get 1 plus 1 secant x plus 1 secant x would be 2 secant x, plus secant x times secant x will be secant squared x. What we can do is break it up into the separate integrals. So that would be integral of 1 dx plus, I'm going to pull the 2 outside the integral sign, 2 times the integral of secant of x dx plus the integral of secant squared x dx. The choice to break it up or not is up to you. However, when you do get terms that require manipulation to get the du factor exact, then you want to break them up. So the integral of 1 dx is just an x. The integral of secant of x is here, so it's going to be 2 times the natural log of the absolute value of secant of x plus tangent of x. plus the integral of secant squared x, remember from the previous video, because secant squared is the derivative of tan, then we know the integral of secant squared x would be tan of x. And don't forget your constant of integration. We only need one constant. We don't need a constant each time for each of those terms, just one constant of integration. Let's try one more example. So in this next example, it's a quotient. We don't usually work with quotients. If we can write it as 1 over u du, we'd do that and use our basic log form, but we're not going to be able to in this case. So what I'm going to do is just use some algebra and break up my numerator and break up this expression into two fractions. So it will be 4 over the sine of 2x plus cosine of 2x over sine of 2x. But my next step is I am going to break these two terms up, and I'm going to pull the 4 out. So I'm going to write 4 times 1 over sine of 2x dx plus the integral of cos of 2x divided by sine of 2x dx. So you could write this as 1 over sine of 2x times cos of 2x and treat it and integrate it using your basic log form. Or you could write this as cotangent of 2x and then use this formula. You'll get the same result. And with this term, I need to use my basic identities to express this as cosecant of 2x. So it's going to be 4 times the integral of cosecant of 2x dx plus, and that's going to be the integral of cotangent of 2x dx. So for this term, we have the pattern cosecant of u. So I'm going to be using this form. U is 2x, so du will be 2 dx. So I need a 2 here, and I divide by 2 here. So now I have the du factor. With this pattern, again, my u is 2x, the du is 2 dx, so I need a 2, so I'll balance it with a 1/2. And now I have it of the form cotangent of u du. So let's plug into our formulas. 4 divided by 2 is 2. The integral of cosecant u du will be the natural log of the absolute value of cosecant of 2x minus cotangent of 2x plus 1/2. Integral of cotangent of u is the natural log of the absolute value of sine of 2x. Practice these basic trig forms of integration, and in the next video we're going to look at some other trig forms. So take care and see you then.